The sky holds secrets that appear only once in a lifetime. We are about to embark on a journey through the top 25 rare astronomical events you should not miss. Cosmic moments so fleeting and spectacular that to see one is to witness a piece of history. By the end of this, you will know exactly which celestial wonders to chase and when to look up. We will explore why a planet can seem to vanish before your eyes and what causes a ghostly glow to appear opposite the sun. Which of these cosmic performances has already been waiting for you? There is no cosmic performance more breathtaking than a total solar eclipse. It begins with a perfect, almost impossible alignment. The sun, the moon, and our Earth fall into a flawless straight line in space. The moon, just the right size and distance, slides directly in front of the sun, casting its shadow upon our world. This shadow races across the planet at thousands of miles per hour, and to stand within it is to experience the path of totality. Day does not simply fade to night. It is a swift and surreal plunge into twilight. The temperature drops sharply. A strange, quiet wind often stirs. Around you, the horizon glows with the colors of a sunset in every direction. And in the sky, where the sun once blazed, now hangs a perfect black hole, wreathed in a shimmering, pearly white halo. This is the solar corona, the sun's outer atmosphere, a sight normally drowned out by the overwhelming solar disk. It is a vision of ethereal beauty, visible only during these precious few minutes of totality. The world around you reacts in wonder. Birds stop singing and return to their nests confused by the sudden night. Nocturnal insects might begin to chirp. It is a profound reminder of our place in a dynamic solar system. To witness this, you must use proper safety glasses at all times before and after totality. Looking directly at the sun, even when it is a thin crescent, can cause permanent eye damage. Only during the brief moment when the sun is completely covered is it safe to look with the naked eye and see the corona in its full glory. If you wish to stand in the shadow of the moon, mark your calendar. On April 8, 2024, a total solar eclipse will cross North America, sweeping from Mexico through the United States and into Canada. Another will grace the skies over Spain and North Africa on August 2, 2027. These are not just dates, they are opportunities to witness one of the universe's most magnificent ballets. While a solar eclipse is a spectacle of hidden light, another event reveals a planet on a precise celestial crossing. The transit of Venus is one of the rarest predictable astronomical events, a slow, silent march of a world across the face of our sun. From our vantage point, Venus appears as a perfectly round black dot, inching its way across the solar disk over several hours. It is not a dramatic blotting out of light, but a demonstration of pure orbital mechanics, a cosmic clockwork that ticks on a scale of human generations. This seemingly simple passage was once the key to unlocking the greatest mystery of our solar system, its true size. For centuries, astronomers knew the relative distances of the planets from the sun, but they did not know the absolute distance, the length of one astronomical unit. Without that one number, the scale of everything else remained a guess. The transit of Venus offered a solution. By observing the event from different points across the globe and timing the precise moments Venus entered and exited the solar disk, astronomers could use parallax, the slight shift in the dot's apparent path, to triangulate the distance to the sun itself. Expeditions were launched to the far corners of the Earth, braving treacherous journeys for a chance to capture this crucial data. The effort culminated in the 18th century, finally giving humanity its first true measure of the cosmos. The pattern of these transits is a lesson in cosmic rhythm. They occur in pairs separated by 8 years, but each pair is divided by more than a century. The last pair happened in 2004 and 2012. The next will not occur until December 2111. To witness one is to see an event that has defined scientific history and will not grace our skies again for over 80 years. Observing it requires the same strict safety precautions as a solar eclipse, using proper solar filters to protect your eyes. It is a patient event, a slow dance that connects us directly to the astronomers of centuries past, all of us united in watching a tiny black dot chart the vastness of space. That slow, predictable dance of a planet is a stark contrast to the sudden, brilliant arrival of a great comet. These are the unexpected rock stars of the night sky, celestial visitors so bright they can outshine the stars and remain visible for weeks even to those in cities. A comet earns the title of great through its sheer brilliance and its spectacular, sprawling tail, a sight that needs no telescope to inspire awe. Comet Hale-Bopp, for instance, dominated the heavens for an incredible 18 months in the late 1990s. Its twin tails, one a stark white dust trail and the other a faint blue ion tail, stretched across a vast portion of the night, a ghostly banner that was impossible to miss. More recently, Comet Neowise graced our skies in 2020, offering a stunning display during a time of global isolation. Its delicate, curved tail, a beacon of beauty that united sky watchers around the world. The true magic of a great comet lies in its unpredictability. These icy bodies originate in the distant, frozen Oort cloud, a vast shell of debris at the very edge of our solar system's gravitational influence. A passing star or the gentle tug of the galaxy can nudge one of these ancient snowballs onto a long, falling orbit toward the sun. As it approaches the inner solar system, solar radiation heats its icy surface, causing it to erupt with gas and dust, forming the magnificent coma and the iconic tail that always points away from the sun. We often do not know they are coming until they are already on their way, a surprise guest from the deepest cold of space. This element of the unknown creates a unique frenzy of excitement among professional and amateur astronomers alike. Will this be the next great one? Its appearance is a transient, living event. You can watch its tail shift and change from night to night, a dynamic spectacle that feels intensely personal. There is no schedule for such grandeur, only the patient hope that in your lifetime, one of these primordial wanderers will swing by close enough to set the sky alight. Sometimes the cosmos offers a double feature, combining two spectacular events into a single performance. A supermoon lunar eclipse merges the moon's closest approach with its journey through Earth's shadow, creating a sight of profound depth and color. First, the supermoon. This occurs when the full moon reaches perigee, its nearest point to Earth in its elliptical orbit. The moon can appear up to 14% larger and 30% brighter than a full moon at its farthest point, a noticeable difference that swells its presence in the night sky. But the real magic begins when this oversized orb starts to vanish. The eclipse unfolds in slow, deliberate phases. It starts subtly with the penumbral stage as the moon enters the faint outer part of Earth's shadow. You might notice a slight, dusky shading on one edge, like a gentle smudge on its brilliant surface. The drama intensifies during the partial eclipse when the dark, central umbral shadow takes a distinct circular bite out of the lunar disk. This bite grows until it consumes the entire moon, marking the beginning of totality. This is when the ordinary moon transforms into the legendary blood moon. It does not disappear into blackness. Instead, it glows with a deep, coppery red. This stunning color is a gift from our own planet. As sunlight passes through Earth's atmosphere, our air acts like a lens, bending the light around the edges of our world and projecting it onto the moon. But our atmosphere also scatters the shorter, bluer wavelengths of light, a process called Rayleigh scattering, which is the same reason our sunsets are red. Only the longer, redder wavelengths survive this journey through our planetary shell, casting the eclipsed moon in a haunting, rust-colored hue. The exact shade can vary from a bright copper to a dark, almost crimson gray, depending on the amount of dust and clouds in Earth's atmosphere at the time. The entire sequence, from the first penumbral touch to the final sliver of light returning, can take several hours, a patient celestial show that requires no special equipment to enjoy. It is a direct, personal connection to the mechanics of our Earth-Moon system, a reminder that we live on a world that casts a long shadow, one capable of painting its companion in the fiery light of every sunrise and sunset on Earth. That deep, coppery light of a blood moon is a solitary spectacle, but sometimes the planets decide to put on a show of their own. A planetary conjunction is a celestial gathering, a moment when two or more planets appear to draw incredibly close together in our night sky. Most conjunctions are a pleasant sight, but every so often, the universe delivers an event so tight it defies belief. The Great Conjunction of 2020 between Jupiter and Saturn was one such marvel. For nights on end, they inched closer until on December 21st, they were separated by just 1/10 of a degree. That is a mere 1/5 the apparent width of the full moon. To the naked eye, the two brightest planets in our sky merged into a single, dazzling point of light, a breathtaking double planet that captivated the world. Through even a small pair of binoculars, you could see the tiny, brilliant disk of Jupiter flanked by its 4 largest moons, with the majestic, ringed sphere of Saturn right beside it, all within the same field of view. It was a family portrait of the solar system's giants presented on a single, celestial stage. This illusion of closeness is a masterful trick of perspective. In reality, Jupiter and Saturn were still hundreds of millions of miles apart. From our vantage point on Earth, we are watching these worlds race along their vast orbital tracks around the Sun. Jupiter laps Saturn roughly every 20 years, so conjunctions between them are not uncommon. But an ultra-close approach like the one in 2020 is exceptionally rare, occurring only once every few centuries. It is the result of a perfect alignment in the flat plane of the solar system, where all the planets orbit. When both Jupiter and Saturn are at the same celestial longitude at the same point in their 20-year dance, we are treated to this incredible spectacle. You do not need any special equipment to enjoy a conjunction. They are some of the most accessible astronomical events, visible from anywhere with a clear view of the sky. To catch the next notable gatherings, keep an eye on the dawn or dusk sky. Venus and Jupiter will have a beautiful close pairing on the morning of August 14, 2024. Another impressive meeting between Mars and Jupiter will occur in the pre-dawn hours of April 20, 2026. These planetary meetups are a gentle reminder that our solar system is in constant, graceful motion, and sometimes that motion creates a moment of pure, shared magic for everyone on Earth to see. A planetary conjunction is a patient ballet, but the sky can also unleash a sudden, breathtaking fireworks display. This is a meteor storm, an event that transforms the silent night into a torrent of light. It is a spectacle far beyond the more common meteor shower. During a typical shower, you might see a dozen or so shooting stars per hour, but in a true storm, that number can explode to over 1,000 meteors every 60 minutes. The sky does not just offer a few fleeting streaks, it erupts in a continuous, silent barrage. The most legendary example is the Leonid storm of 1966. Eyewitnesses in the southwestern United States described it as a true blizzard of meteors, with rates peaking at an astounding 40 per second. For a few frantic minutes, it was less about counting individual streaks and more about witnessing the sky itself seem to crack and fall. A more recent, though less intense, encore occurred in 2001, when the Leonids again delivered a powerful display of several thousand meteors per hour. The origin of this cosmic fury lies in the debris left behind by comets. As a comet travels through the inner solar system, it sheds a cloud of dust and pebbles along its orbit. Our planet, in its yearly journey around the Sun, plows through these streams of debris. Most showers happen when we pass through a generally distributed cloud. A storm, however, is born from something far more concentrated, a dense ribbon of material that the comet ejected during a particular pass, perhaps centuries ago. It is the difference between sailing through a light mist and hitting a narrow, powerful river. This is what makes meteor storms so notoriously difficult to predict. Hitting that narrow debris trail perfectly depends on the precise gravitational dance between Earth and the comet's dust. Even with our best models, we cannot always be certain if we will graze the edge of the stream or pass directly through its heart. To give yourself the best chance of witnessing such an event, preparation is key. You need a dark sky far from the glow of city lights, a reclining chair or a blanket. It will let you look straight up comfortably for long periods. Most importantly, you need patience. Allow your eyes at least 20 minutes to fully adjust to the darkness. Do not look at your phone, as its bright light will ruin your night vision. Simply lie back, watch the entire sky, and wait. When a storm arrives, there is no mistaking it. The heavens themselves seem to come alive, offering a display of pure, raw celestial power that is both humbling and utterly unforgettable. The silent fury of a meteor storm gives way to a far more delicate cosmic alignment. Picture the steady, unwavering light of a brilliant star like Aldebaran, the red eye of the constellation Taurus. Now watch as the wandering planet Venus glides silently toward it. For a few breathtaking minutes, the planet's disk makes a perfect, slow-motion rendezvous, its edge just kissing the star's pinpoint of light. Then, in an instant, the star vanishes. It is not fading or dimming. It is simply gone, blotted out by the dark limb of another world. This is an occultation, a celestial disappearance act that is both a beautiful spectacle and a powerful scientific tool. That moment of disappearance and the equally precise moment of reappearance are measured to the fraction of a second by observers across the globe. This data is pure gold for astronomers. By timing how long the star winks out from different locations, scientists can map the precise size and shape of the planet's atmosphere, detecting subtle layers and even weather patterns. It also provides an incredibly accurate check on our knowledge of the orbits of both the planet and the distant star, refining our cosmic maps to an astonishing degree. To witness such an event, you will need a telescope, as the star and planet appear too close together for the naked eye to separate the drama. The best views come from setting up in a location with a clear, steady sky. Patience is key, as the entire event hinges on a few critical seconds. One of the most anticipated events for many sky watchers is the ongoing series of occultations of the bright star Regulus by the planet Venus. These events are relatively rare, and catching one requires being in the right part of the world at the exact right time. To see a planet steal the light of a distant sun is to witness the clockwork of the solar system in its most precise and intimate form, a reminder that even the smallest motions in our celestial neighborhood can create moments of pure observational magic. That precise disappearance of a star by a planet is a masterclass in celestial alignment, but our own atmosphere can create its own fleeting magic. The green flash is an emerald spark that ignites for just a second or two as the very last sliver of the sun vanishes below a distant horizon. It is not an illusion, but a spectacular consequence of light bending through the air around us. The sun's white light is actually a mixture of every color, and as its rays slice through the thickest part of Earth's atmosphere near the horizon, our air acts like a weak prism. This effect, called atmospheric refraction, bends each color by a slightly different amount. Blue and green light are bent more sharply than red and orange light. For a fleeting moment, just as the red disk of the sun disappears, the more strongly bent green light can travel over the curve of the Earth to your eyes, creating that brilliant final flash. The blue light is usually scattered away by our atmosphere, which is why the sky appears blue, leaving green as the champion of this brief chromatic race. Catching this event demands perfect conditions. You need an exceptionally clear day with stable, clean air, free of haze or pollution. The horizon must be sharp and flat, which is why the open ocean is the most famous stage for this phenomenon. A calm sea provides that perfect, unbroken line against which the sun can perform its final trick. Even over the water, it remains elusive. Many veteran sailors have spent a lifetime at sea and only seen it a handful of times. Certain coastlines are legendary for increasing your odds. The wide vistas of the Pacific Ocean, viewed from places like Hawaii or the California coast, are prime locations. The key is persistence. You must watch the sunset with unwavering attention every single evening, focusing on the very top edge of the sun as it makes its final descent. Blink and you will miss it. That single, brilliant flash of green is a reward for patience, a tiny, perfect secret shared between you, the sun, and the planet you stand on. The moon itself can become the agent of a stunning disappearance. A lunar occultation of a planet is a celestial ballet of remarkable precision, where our own moon glides silently in front of a distant world, swallowing its light for a brief, magical interlude. Imagine training your telescope on Jupiter, its striped cloud bands and 4 Galilean moons clearly visible. You watch as the moon's dark, leading edge, devoid of earthshine, approaches the brilliant planet. There is no sound, no fanfare, only the slow, inevitable creep of the lunar limb. Then contact. The edge of Jupiter's disk touches the moon, and within a minute or two, the entire planet, along with its entourage of moons, is completely hidden from view. It simply vanishes behind the stark, cratered landscape of the moon. The reverse is just as dramatic. After a calculated wait, a brilliant point of light erupts from behind the moon's sunlit edge, quickly swelling back into the full, glorious disk of the gas giant. These events are a powerful demonstration of the moon's rapid orbital motion, as it travels its own diameter in space roughly every hour. Because the moon is so close to us, its position in the sky shifts noticeably depending on your location on Earth. This means an occultation visible from one city might be a near miss from another just a few dozen miles away. To know when and where to look, you can use free astronomy software or mobile apps like Stellarium. By entering your exact location, these tools will show you a precise timetable for when the moon will pass in front of planets and bright stars in your local sky. Observing a planet being occulted by the moon is one of the most dynamic sights in amateur astronomy, a direct, real-time connection to the clockwork of our celestial neighborhood that turns the sky into a living, moving map. That same moon that hides planets can also help obscure one of the sky's most elusive glows. High above the interference of our atmosphere, a faint celestial phenomenon awaits the most patient observers. Known as the Gegenschein or counterglow, this is a soft, oval-shaped patch of light visible only in the deepest, darkest night skies, positioned exactly opposite the sun. You are looking at a reflection of sunlight, but not from any single object. This glow comes from countless microscopic dust particles scattered across the entire inner solar system. These tiny grains, remnants of asteroids and comets, form a vast, thin cloud that spans the plane of our planetary system. When the sun is directly behind you, its light strikes these distant particles head-on and reflects straight back toward your eyes in a concentrated spot, creating this incredibly subtle illumination. It is the same principle that makes a foggy road appear brightest in your car's headlights, but on a cosmic scale. This makes the Gegenschein far more challenging to see than its cousin, the zodiacal light. The zodiacal light appears as a faint, tilted pyramid of light stretching up from the horizon after sunset or before sunrise, which is sunlight scattered from the same interplanetary dust but at a shallower angle. The Gegenschein is different. It is not a cone of light near the horizon. It is a diffuse, almost ghostly oval high in the midnight sky with no sharp edges to define it. Seeing it is the ultimate test of a truly dark sky. You need a location far from any city lights on a night when the moon is completely absent. Even a sliver of moonlight will wash it out entirely. Your eyes must be fully adapted to the darkness for at least 30 minutes. You cannot look directly at it. Instead, you must use averted vision, looking slightly to the side of the suspected area to allow your more light-sensitive rod cells to detect its ethereal presence. To find it, you must first locate the point in the sky directly opposite the Sun, a spot that changes throughout the year as Earth orbits. On a perfect night, it reveals itself not as a bright object but as a subtle absence of darkness, a place where the black of space seems just a little less black than the surrounding void. Spotting the Gegenschein is a quiet triumph, a personal confirmation that you are looking through a window filled with the fine dust of creation itself. That same ethereal dust cloud is a faint and constant presence, but our atmosphere can suddenly ignite with a firestorm of color that defies all expectation. An aurora at low latitudes is a profound anomaly, a polar spectacle that has broken free from its icy cage. Normally, the northern and southern lights are confined to a ring around the Earth's magnetic poles, a celestial crown seen only by those in the high Arctic or Antarctic. Yet sometimes the sky erupts in crimson and violet curtains over Rome, or emerald ribbons dance above the deserts of Arizona. These are not mere curiosities. They are a direct message from the Sun, a sign of a celestial battle raging in the space around our planet. The entire event begins with a solar storm. The Sun's tangled magnetic fields can snap, violently hurling a colossal bubble of superheated gas and magnetic force into space. This is a coronal mass ejection, a billion-ton cloud of plasma traveling at millions of miles per hour. When one of these titanic storms is aimed directly at Earth, it takes a day or so to cross the void. Upon arrival, it slams into our planet's protective magnetic shield, our magnetosphere. The impact is so immense it distorts our magnetic field, compressing it on the day side and stretching it into a long tail on the night side. This violent interaction funnels vast numbers of solar particles down toward the poles at incredible speeds. When these particles collide with atoms of oxygen and nitrogen in our upper atmosphere, they transfer energy, exciting them. As these atoms calm back down, they release that energy in the form of light. Oxygen glows green or red, while nitrogen produces blues and purples. During an extreme solar storm, the influx of energy is so powerful that it overwhelms the usual polar pathways. The auroral oval, that ring of light, expands dramatically, pushing south in the northern hemisphere and north in the southern hemisphere, bringing its otherworldly glow to millions who have never seen it before. History is filled with these spectacular invasions. The Carrington event of 1859 was so powerful that auroras were reported in the Caribbean and Hawaii. Miners in the Rocky Mountains woke in the middle of the night, convinced the dawn had arrived because the sky was so brilliantly red. Telegraph systems, the high-tech marvel of the age, failed spectacularly, with some operators reporting that they could send messages even after disconnecting their batteries, powered by the electrical currents flowing through the air itself. A more recent example was the Halloween storms of 2003, when intense auroras were seen across the southern United States and Europe, a vivid display of our star's raw, untamed power. Witnessing an aurora far from the poles is a truly historic event. It requires a perfect and often violent alignment of solar fury and terrestrial magnetism. To have a chance, you must follow space weather forecasts from agencies like NOAA. When a strong coronal mass ejection is predicted, even those in temperate latitudes should look north on clear, dark nights. You are not just watching a beautiful light show, you are seeing the outer defenses of our planet being tested, a visible reminder that we are connected to our active and sometimes tempestuous star by an invisible, energetic bridge. That same solar stage that hosted Venus can also feature its smaller, faster-moving sibling. A transit of Mercury sees the innermost planet pass directly between the Earth and the Sun, presenting itself as a perfectly round, ink-black dot inching across the solar disk. While similar to the transit of Venus in principle, the experience is dramatically different. Mercury is a much smaller world, only about 1/3 the size of Venus, so its silhouette against the Sun appears minuscule. You cannot see it without optical aid. It looks like a tiny, precise speck of pepper on a brilliant, glowing plate. This smaller size is traded for a much higher frequency. Because Mercury orbits the Sun so quickly, transits happen roughly 13 or 14 times each century. The next one will occur on November 13th, 2032, followed by another on November 7th, 2039. Despite their relative regularity, each transit is a compelling event, a chance to witness the mechanics of our solar system in action. The primary challenge and absolute necessity is observing it safely. You must never look directly at the Sun without proper protection. The safest and most accessible method is projection. You can use a pair of binoculars or a small telescope to project a magnified image of the Sun onto a white sheet of cardboard or a wall. You will see the Sun's disk clearly, and that tiny black dot that is Mercury will be unmistakable as it begins its slow journey. Alternatively, you can use certified solar viewing glasses, but because Mercury is so small, you will likely need a telescope with a proper solar filter to actually resolve its disk against the Sun's immense brightness. Watching this event connects you to a long history of astronomical discovery. Transits of Mercury were used to study the planet's orbit and even helped refine our understanding of the Sun's distance. To see that tiny, dark world silhouetted against our star is to witness a perfect alignment, a reminder that even the smallest planets cast long shadows across space when they step into the light. Our language holds onto old definitions long after their meaning has shifted. The true blue moon is not simply the second full moon in a calendar month. That is a modern and far more common interpretation. The original and more authentic definition is tied to the rhythm of the seasons. An astronomical season, the period between a solstice and an equinox, typically contains 3 full moons. But because the lunar cycle is about 29.5 days long, and our seasons are a bit longer, a misalignment slowly builds. Every 2 or 3 years, a single season will squeeze in a 4th full moon. According to the old rule, it is that 3rd full moon of the 4 that earns the title of blue moon. This traditional definition makes the event genuinely rare, occurring only about 7 times every 19 years. The name itself is a historical puzzle. Some trace it to the Old English word beware, which could mean to betray. In this context, the extra moon betrayed the usual order of the lunar calendar, complicating the scheduling of church festivals. Other theories suggest it was simply a marker for an unusual, or blue, event in the almanacs of farmers. The most important thing to remember is that a blue moon does not mean the moon will appear blue in the sky. That is an entirely different and far more rare phenomenon caused by massive volcanic eruptions or immense forest fires that fill the atmosphere with particles of a specific size, scattering red light and allowing only blue hues to pass through. A seasonal blue moon will look like any other brilliant full moon, a familiar face in a slightly unusual position in the annual dance. Its rarity is not in its appearance, but in its timing, a subtle reminder that our human calendars are always trying to catch up to the timeless and often inconvenient cycles of the cosmos. There is nothing quite so startling as a star simply switching off. One moment it is there, a familiar point of light you have seen countless times. The next it is gone, as if a cosmic hand has reached out and snuffed it. This is the dramatic signature of an asteroid occultation, a fleeting event where a small, dark rock in the asteroid belt drifts directly in front of a distant sun. For a few precious seconds, the asteroid casts a tiny, moving shadow upon the Earth, and anyone standing in that shadow path witnesses a star vanish and then reappear. The event is incredibly brief, often lasting less than 10 seconds, and the path of that shadow is razor thin, sometimes only a mile or 2 wide. This is not a spectacle of light, but of precise, measurable darkness. That brief wink in the night sky is a powerful scientific tool. By timing the exact moments the star disappears and reappears from multiple locations, astronomers can perform a kind of celestial sonogram. They combine all the timed observations to trace out the silhouette of the asteroid as it passes in front of the star. This allows them to measure the rock's precise size and shape, revealing whether it is spherical, elongated, or even a contact binary, two smaller bodies gently resting against each other. This data is vital. It helps us understand the composition and structure of these primordial building blocks of the solar system. And for any asteroid that might one day pass close to Earth, knowing its exact shape is crucial for predicting its orbit and potential future path. This is where you become a direct participant in the process. You do not need a giant telescope or a degree in astrophysics to contribute. Amateur astronomers with modest backyard setups are the lifeblood of asteroid occultation science. By setting up a telescope, a video camera, and a precise GPS time signal, you can record the event and provide a critical data point. Organizations like the International Occultation Timing Association coordinate these efforts, providing predictions for when and where these star coverings will occur. Your single, carefully timed observation from your own backyard becomes part of a global network of data, helping to map the contours of a world millions of miles away. To capture one is to become a citizen scientist, your eyes and equipment joining a collective effort to measure the shadows cast by invisible worlds. The silent, meticulous work of measuring asteroid shadows is a world away from the sudden, violent death of a star. A naked-eye supernova is the ultimate cosmic catastrophe, a stellar explosion so brilliant it can outshine the combined light of every other star in its home galaxy. For a few glorious weeks, a brand new, intensely bright star appears where none existed before, a beacon of pure destruction visible even from the heart of a light-polluted city. History records such events, and they change our understanding of the universe forever. In the year 1054, Chinese and Arab astronomers documented a guest star so luminous it was visible in broad daylight for 23 consecutive days. This was the supernova that would eventually form the Crab Nebula, a tangled, expanding cloud of gas that still glows today, nearly 1,000 years later. To the observers of the time, it was a celestial omen. For us, it is a permanent cosmic landmark, the aftermath of a star that tore itself apart. The science behind this spectacle is a story of gravitational collapse and rebirth. A supernova occurs when a massive star, at least 8 times heavier than our Sun, exhausts the nuclear fuel in its core. The fusion reactions that have supported it against its own immense gravity suddenly cease. With no outward pressure to hold it up, the star's core collapses in less than a second, crushing itself into an impossibly dense neutron star or even a black hole. The outer layers of the star, now without a foundation, rebound off this new, ultra-dense core and explode outward in a shockwave of unimaginable power. For a brief period, this single dying star can radiate more energy than our Sun will over its entire 10 billion-year lifetime. The light we see is the final, defiant flash of that stellar material being blasted into space, seeding the galaxy with the heavy elements forged in its heart. The iron in your blood and the calcium in your bones were once created in such a cataclysm. We are quite literally star dust. This leads to the modern fascination with the red giant Betelgeuse, the star that forms the shoulder of the constellation Orion. It is a ticking time bomb, a supergiant star nearing the end of its life. Its recent dramatic dimming events have sparked global speculation that its explosion could be imminent. In astronomical terms, imminent could mean tomorrow or 100,000 years from now, but when it does happen, it will be a spectacle for the ages. Betelgeuse is so close that a supernova could shine as brightly as a full moon, casting sharp shadows at night and remaining visible during the day for months. It would be a harmless but utterly transformative event, a constant reminder of the dynamic, violent, and creative universe we inhabit. To see a new star ignite in the familiar pattern of Orion would be to witness the end of a cosmic era and the beginning of a new legacy, one that would be written in light across our sky for generations. While the Jejensheen is a subtle glow high in the midnight sky, its source creates a far more dramatic sight near the horizon. The zodiacal light is a vast, ethereal pyramid of light that reaches up from the western horizon after twilight fades, or from the eastern horizon before the dawn begins to break. It appears as a soft, tilted cone, broad at the base and tapering gently upward, following the same path the sun and planets travel across the sky, known as the ecliptic. This is not the lingering glow of sunset, but something far more cosmic. You are seeing sunlight reflected off countless microscopic dust grains that fill the inner solar system, a vast, flat disk of debris that stretches from the sun out beyond the orbit of Mars. These particles are the scattered remains of asteroid collisions and the dusty trails of comets that have passed through our neighborhood over millions of years. When the angle is just right, with the sun far enough below the horizon to create a dark sky but still able to illuminate this distant dust cloud, the zodiacal light reveals itself as a faint, luminous beacon. Observing it requires a perfect escape from light pollution. You need a truly dark sky sight, far from the orange glow of any city. The best opportunities come during moonless nights in the spring, when the ecliptic stands nearly vertical in the western sky after sunset, or in the autumn before sunrise. Your eyes must be fully adapted to the darkness for at least 20 minutes. Do not look for it directly. Instead, use averted vision, glancing slightly away from the area to allow your peripheral vision, which is more sensitive to faint light, to detect its soft radiance. To stand beneath the zodiacal light is to have a direct visual connection to the architecture of our solar system. You are not just looking at stars. You are seeing the dusty floor of our celestial neighborhood, a sunlit highway made visible only in the deepest dark. A planetary parade offers a different kind of spectacle, a grand open house of our solar system. Instead of a single dazzling point, the sky presents a loose alignment, with several worlds strung out across the same general region of the heavens. This celestial gathering is not a matter of planets being physically close together in space, but a beautiful trick of perspective from our vantage point here on Earth. All the planets orbit the sun in roughly the same flat plane, like marbles rolling on a giant, invisible table. When their orbits bring them to positions where, from our viewpoint, they appear in the same patch of sky, we are treated to this family portrait. The key to enjoying the show is knowing who is who. Venus is unmistakable, a brilliant, steady white beacon that never strays far from the sun, dominating either the dawn or dusk sky. Jupiter follows as the second brightest, shining with a calm, creamy white light. Mars is the rusty red wanderer, its distinct hue a giveaway. Saturn glows with a muted, golden-yellow tint, a serene and steady presence. And elusive Mercury will hug the horizon, a flickering light that is challenging but rewarding to spot. Each planet holds its position against the background stars, and watching them shift from night to night is a lesson in orbital speeds. The next significant parade will grace the pre-dawn sky in the summer of 2024. For several weeks, you will be able to see Mars, Jupiter, and Saturn spread out in a line, with the possibility of Mercury and Venus joining the display low in the east just before sunrise. The best time to observe is about an hour before the sun comes up, from a location with a clear, unobstructed view of the eastern horizon. No telescope is needed. Simply step outside, let your eyes adjust, and take in the quiet majesty of multiple worlds sharing the same stage. A gentle reminder that our entire solar system is on display, just waiting for us to look up. A brilliant ring of light sometimes encircles the moon, a perfect circle of shimmering radiance against the deep night. This is the 22-degree halo, a phenomenon born not in deep space, but high within our own atmosphere. It appears when a thin veil of cirrus clouds drifts far overhead, clouds composed not of water droplets but of countless millions of microscopic, six-sided ice crystals. These crystals act like tiny, floating prisms, bending the moonlight as it passes through them. The specific geometry of their hexagonal shape dictates the angle of this bending, creating that perfect 22-degree radius circle around the moon. You can test this yourself. Stretch out your arm and make a fist. The distance from your knuckles to the center of the halo is roughly the span of your fist held at arm's length. The light you see is not just a white ring. It often carries a soft, internal rainbow with a reddish glow on the inside of the circle and a faint blue on the outside, a subtle hint of the prismatic magic at work. The sun can create an identical halo, though its intense glare usually makes it harder to see without blocking the sun itself with a building or a tree. This is where the sun dogs come into play. Also known as parhelia or mock suns, these are two intensely bright spots of light that appear on either side of the sun, often right on the edge of the halo circle if one is present. They form when countless plate-shaped ice crystals drift down through the air like tiny, falling leaves, their flat faces nearly horizontal. These aligned crystals act like a vast array of mirrors, reflecting and focusing the sun's light to the sides and creating those brilliant false suns. Sun dogs often shine with spectacular colors, ranging from red on the side closest to the sun to a brilliant blue farther out. For centuries, these atmospheric marvels were not just beautiful curiosities. They were vital tools for weather prediction, deeply embedded in folklore around the world. A lunar halo or a display of sun dogs was widely seen as a reliable harbinger of approaching bad weather, often rain or snow within the next 24 to 48 hours. There is solid science behind this old wisdom. The high, thin cirrus clouds that create these halos are typically the leading edge of a warm front and an associated low-pressure system. As the front approaches, the clouds thicken and lower, eventually bringing precipitation. So when you see that ghostly ring around the moon, you are witnessing the first delicate brushstrokes of a much larger weather system painting its way across the sky. To see these effects for yourself, you only need to look up on a day or night when those wispy, feathery cirrus clouds are present. No special equipment is needed, just an awareness of the sky above. It is a reminder that some of the most captivating cosmic events are not light years away, but are painted in the icy canvas of our own planet's air. Even the debris of a famous comet can create an annual spectacle. The Eta Aquariid meteor shower each May and its sibling the Orionids each October are gifts from Halley's comet. These are not random streaks of light, but the scattered remnants of the most celebrated comet in history. As Halley journeys around the sun, it leaves behind a river of dust and tiny particles along its entire orbit. Every year, our planet plows through this ancient stream twice, once in spring and again in autumn, creating two distinct but related showers. Most years are reliable, offering a steady 20 to 30 meteors per hour at their peak. But occasionally, the Earth passes through an unusually dense clump within that river, a pocket of material ejected by the comet centuries ago. In those special years, the zenithal hourly rate can surge dramatically, potentially doubling or more, transforming a pleasant show into a dazzling outburst of swift, bright meteors. The Eta Aquariids are renowned for their speed. These meteors slam into our atmosphere at a breathtaking 148,000 miles per hour, leaving behind persistent glowing trails known as trains that can hang in the air for several seconds. The best strategy for watching is to plan for the pre-dawn hours. Find the darkest sky you can, lie back on a reclining chair or blanket, and let your eyes fully adjust. You do not need to stare directly at the radiant point, the spot in the constellation Aquarius from which the meteors appear to originate. Instead, look about 45 to 90 degrees away, taking in as much of the sky as possible. This is where you will see the longest and most spectacular trails. The connection to Halley's comet makes every Eta Aquariid or Orionid meteor feel like a piece of living history. You are not just watching dust burn up, You are witnessing the lingering breath of a cosmic traveler, a ghostly presence that returns to our skies long after the comet itself has vanished back into the depths of the solar system. A grazing occultation transforms the moon's edge into a dramatic, mountainous skyline. Instead of a star cleanly vanishing behind a smooth, dark limb, it appears to skim the very top or bottom of the lunar disk. What you witness through a telescope is a breathtaking flicker show. The star does not disappear all at once. It dances behind the peaks and valleys of the moon's rugged polar regions, winking in and out of existence multiple times over a minute or two. One moment it is a steady point of light, the next it is gone, only to reappear an instant later as it clears a lunar mountain, then vanish again into a deep valley. This rapid-fire performance is a direct, real-time topographical map of a world 250,000 miles away. The precise timing of each disappearance and reappearance from multiple observers on the ground allows scientists to build an exquisitely detailed profile of the lunar limb, refining our knowledge of the moon's exact shape and orientation in space. This data is crucial for future precise lunar landings and for understanding the subtle gravitational nudges that affect the moon's orbit. To chase one of these events, you need to be in the right place at that exact moment, as the shadow path for a graze is incredibly narrow, sometimes only a few hundred feet wide. Organizations like the International Occultation Timing Association provide detailed predictions and maps showing the precise track where the graze will be visible. Your own recorded timing of the star's flickering journey can become a valuable piece of that scientific puzzle, turning a beautiful observation into a direct contribution to our celestial cartography. There is a moment when the crescent moon holds a secret in its arms. For a few days after the new moon or before it returns, you can see the entire full circle of the moon suspended in the sky. The bright, sunlit crescent is familiar, but the rest of the disk is not completely black. It is gently illuminated by a soft, ghostly light, revealing the moon's familiar seas and highlands in subtle gray detail. This is Earthshine, often called the Da Vinci glow, a phenomenon where the moon is lit by the light of our own world. The sun's rays strike the day side of Earth, illuminating our planet's clouds and oceans. This light, now Earth's light, is reflected back into space, softly painting the lunar landscape in a second-hand glow. You are seeing our planet as a mirror, a brilliant blue and white marble in the blackness, casting its own gentle radiance upon the moon. This is a direct demonstration of a concept called albedo, which is simply the measure of how much light a surface reflects. Our Earth, with its bright clouds and vast oceans, has a relatively high albedo, making it a surprisingly good mirror in space. Leonardo da Vinci was the first to correctly unravel this mystery centuries ago. He realized that the faint glow on the dark part of the moon must be sunlight bouncing from our own world's oceans and then onward to the lunar surface. To see the Da Vinci glow for yourself, look for a slender crescent moon low in the western sky just after sunset, or in the eastern sky just before sunrise. The best views come when the crescent is thin, typically 2 to 4 days after the new moon. The effect is subtle and beautiful, a quiet celestial handshake between our world and its companion, a reminder that even in its darkest phase, the moon never fully leaves us in the dark. For a brief, brilliant moment, it seemed as though humanity had learned to build its own stars. The iridium flare was a man-made marvel, a sudden and silent burst of light that could outshine Venus as it raced across the night. It was not a natural phenomenon, but a carefully engineered one. Specific communication satellites, part of the original Iridium constellation, were built with 3 highly polished, door-sized antenna panels. As they tumbled in orbit, these flat, mirror-like surfaces would occasionally catch the sunlight just right, reflecting a concentrated beam of light down to a very specific location on Earth's surface. For anyone standing in that precise spot, the result was breathtaking. A faint satellite would swiftly brighten over a few seconds, flaring into an intense, dazzling point before fading back into the darkness just as quickly. It was a predictable, personal light show, a secret handshake between the cosmos and those who knew when and where to look, but that era is now closing. The original Iridium satellites are being deliberately deorbited, burning up in the atmosphere as they are replaced by a new generation designed not to produce these spectacular flares. The intentional star is going extinct, a deliberate sacrifice for a clearer sky. This deliberate end to one kind of sky pollution opens a much larger debate about the future above us. We are now entering the age of the mega constellation, with plans to launch tens of thousands of new satellites into low Earth orbit. These vast fleets are designed to provide global internet coverage, connecting the most remote corners of our planet. The scientific and astronomical community watches this rapid expansion with deep concern. From a pristine dark sky site, you can now see not just a handful of satellites after sunset, but dozens, even hundreds, moving in silent, steady trains that march across the constellations. For the unaided eye, it is a fundamental change in the character of the natural night. For professional astronomers, the challenge is even more severe. The trails left by these bright, reflective objects can completely ruin long-exposure images from giant ground-based telescopes, slicing through delicate observations of distant galaxies and faint asteroids. The very data used to understand the universe is being scratched out by the infrastructure of our connected world. The question we now face is a profound one, balancing global connectivity against our ancestral view of the cosmos. Can we have both, or are we writing a new, permanent pattern across the heavens, one that forever separates us from the pristine sky our ancestors knew? That debate over our changing sky brings us back to a celestial body whose brilliance is never in question. Venus reaches a pinnacle of luminosity that can outshine everything except the sun and moon, a moment astronomers call its greatest brilliancy. This is not a random surge in power, but a precise celestial balancing act between proximity and presentation. As an evening star, Venus swings away from the sun in the western sky after sunset, growing larger in our view as it draws closer to Earth on its inner, faster orbit. But it also presents an increasingly slim crescent phase, like a tiny, luminous banana. Its greatest brilliancy occurs at the sweet spot, when its large, crescent disk is still wide enough to reflect a tremendous amount of sunlight back to us before it shrinks to a thinner sliver. It is a cosmic trade-off where its nearness and its sunlit face combine to create that stunning beacon. The same phenomenon occurs in reverse when Venus is a morning star blazing in the east before dawn. You can actually witness this changing phase for yourself with a small telescope. As Venus approaches its greatest brilliancy as an evening star, you will see it not as a full disk, but as a beautiful, fat crescent. It is a miniature version of our own moon's phases, playing out over months. To catch this brilliant world at its peak, mark your calendar for its next greatest brilliancy as an evening star on March 24, 2025. It will then reappear as a dazzling morning star, reaching its peak on September 19, 2027. For the best view, find a clear western horizon after sunset for the evening apparition, or an eastern horizon before sunrise for the morning show. Through a telescope, the sight of its crescent phase is a humbling reminder that we are looking at another world, one that is not a steady point of light, but a dynamic, sunlit sphere hanging in the void. The same precision used to map the moon's edge can be aimed at targets far beyond its orbit, at worlds so distant they appear as mere pinpricks of light. A star's occultation by a large asteroid or dwarf planet is the ultimate celestial stealth mission, where a small, dark world glides silently in front of a distant sun. For a few critical seconds, the star's light winks out, not from a familiar planet or our moon, but from a frozen, primordial relic drifting in the blackness of the asteroid belt or the Kuiper belt. Observing this requires being in exactly the right place at a precisely predicted time. as the shadow path cast by an object like the asteroid Vesta or even the dwarf planet Pluto is incredibly narrow, often just a few miles wide. This is not a casual stargazing event, it is a scientific treasure hunt. That momentary disappearance is a powerful probe. By timing the exact duration of the occultation from multiple locations, astronomers can measure the object's diameter with astonishing accuracy, often to within a single mile. But the data holds even more secrets. If the object has a thin atmosphere like Pluto, the starlight does not snap off and on like a switch. Instead, it flickers and dims gradually as it passes through the layers of this alien air, revealing its pressure, density, and composition. These events are our primary tool for studying the atmospheres of worlds too far for our probes to visit anytime soon. You can be part of this discovery. Organizations like the International Occultation Timing Association and the European Space Agency's Gaia project issue detailed predictions for these rare events, calling upon a global network of amateur astronomers to set up their telescopes along the predicted shadow path. Your single observation, a carefully timed video recording from your backyard, can be the crucial data point that confirms the size of a distant asteroid or detects a tenuous atmosphere on a frozen dwarf planet. To capture one is to become a direct extension of human curiosity, your equipment helping to measure the shadow of a world millions of miles away, turning a brief flicker in the night into a permanent entry in our map of the solar system. From the ghostly shimmer of the Jejunshine to the fiery death of a star, these 25 events paint a portrait of a cosmos in constant, spectacular motion. Each one offers a unique key to understanding our place in the universe, whether it is the predictable clockwork of a planetary transit or the sudden, brilliant surprise of a great comet. Their rarity spans from a few years to entire human generations, making every sighting a personal encounter with history. To witness them, you become part detective and part poet. You learn to read the celestial calendar, to seek out the refuge of a truly dark sky, and to cultivate the patience that allows for a little luck. The universe does not perform on demand, but it always rewards those who are prepared to watch. So find the next event on your personal horizon, mark it in your calendar, set an alarm, and when the time comes, simply step outside and look up. The greatest show is free for all, and your front row seat is waiting. Tell us in the comments which of these cosmic wonders you have been lucky enough to see, or which one you are now dreaming of